So if you can see the video, you see that we're running a dual shaker tests. We'll be showing our module for multi-shaker testing in RULA software. Today we'll be testing the Barbie vehicle to make sure it's safe for her to drive the roads. And we will cover some specifics of our multi-shaker module. First of all, what we're trying to show is that multi-shaker subsystem is quite easy in RULA software, and it's intuitive, it's easy to set up, same as single shaker tests. We'll be talking about sign, random, shock, superimposed tests, and field data replication. We will talk about some specifics like what special features we're offering and what differentiates RULA controllers in our technology from some other brands. Yeah, we're hoping to have your questions and answer them as we go. Today I have here my colleague, Philip Stoomscheis, the software engineer who's in charge of our presentations. And I'm going to give him the microphone. And I also have here the head of software development, Ilya Sokolovs, who will deal with more difficult questions if you have them. So if there's something which is bothering you or not working, please take this chance and ask your question. Okay, I see that the majority of attendees are already here, so we're ready to start. And without further delay, let me pass the microphone to my colleague, Philips. You're welcome.
Hello, everyone. In this webinar, we're going to talk about multi-shaker vibration tests. We're going to discuss the available multi-shaker tests in our software. And before we start, let me show you our setup and explain some basics. I hope this webinar will be interesting and worthwhile. First of all, why are multi-shaker tests so popular? We use multi-shaker tests in different cases. First of all, when we need to test large objects or protruded objects, we can't place them on a single shaker. So in that case, we use multiple shakers in our setup. Also, multi-shaker tests reduce test time. In some cases, it may be rather important. And the last thing, multi-shaker tests help to precise simulation of real-time environment. And I think that's a rather useful feature. And in that case, multi-shaker tests can help you. In our software, we have different features. For example, we can work with from 2 to 8 shakers at the same time. We have multi-shaker sign, random, shock, mixed tests, and field data replication. Also, our frequency range in multi-shaker tests is up to 20 kilohertz. And we use cross-matrix control in our software, and we provide minimum phase shift. Now this value is less than 1 degree. I think now let's continue and I'll explain our setup. In this webinar, we have a regular vibration set for multi-shaker tests. We have one RLC21. We're using 2 RULA RL-A200 amplifiers and 2 shakers. On the shakers table, we have 2 accelerometers. They have IP type and their sensitivity is 10 millivolts per G. Also, you can see a pink car placed on the shakers. And in this webinar, it won't have any sensors on this car, but all vibrations will be shown by this car movement. And now I think we can start with our software. Let's open this probe cell. And our first step is to configure our channels. We go to Configuration tab and select Channels button. Let's create new configuration and call it Current Webinar. We have two accelerometers, so we need to set the first and the second channel. We set their sensitivity as 10 millivolts per G and change their type. They are IEP. Then we go to Analog Outputs tab, and we need to select the second output channel as a control one. Now we created our configuration. Now we're ready to start with the Multishaker sign test. Let's open it. Here we see our profile, but we need to change it. Let's press Edit button. Our profile will consist of two lines. The first one will be from 10 Hz to 20 Hz. The start amplitude will be 0.1 G and the end amplitude will be 0.5 G. Let's add another profile line. Our end frequency of the profile is 100 Hz and the end amplitude is 0.5 G. We press apply. Here you can see our profile. And then we need to check our control loops. Here you can see axis name and two loops here. In our software, you can shake your object in multiple axes. So in that case, you need to add them with this button. But in this setup, where we have only one axis, it's Z axis. But we have two shakers, so we need to have two loops. Here we will set the second output, and here you can see that our profile is selected. We need to check our shaker. This shaker is selected by default one, and we're using this model. Also, we have another interesting feature, which is called phase difference. Let me explain it. In different cases, we need to create a profile with phase differences, and in that case you type in your phase difference value, and after that you get the required impact. For example, in these pictures you can see that one control loop is shown by the blue line, but when we have a phase shift, the second loop will be as shown on the orange picture. So now we can continue in our software. Okay, let's go to Schedule tab. We will run our profile and don't change the schedule. After that, we need to set up our channels. We have current webinar configuration, and we are not using the third and the fourth channel, so we will disable them. After that, we press apply and save it. Our profile is done, and now we are ready to start the test. We need to wait some time for the startup. So our software is loading, and we have some questions now, I think.
Yeah, we already have a question. A user is asking, what sensors are you using?
As I mentioned earlier, we're using two IEP sensors, and their sensitivity is 10 millivolts per G.
Thank you.
I think we have some issues now. Let me check. I'll check the amplifiers now. Let's start the test again. I think now the test is starting, and let's open oscilloscope. I think the test will run in a few seconds, and now let me check our outputs and type me if there are some issues with the video, but I think everything is okay. Let me scale. Here you can see that our car is shaking, and I think everything is correct now. Here you can see that we are moving really close to our profile, and the car is shaking right now. I think we got an emergency stop. It's because we got a resonance at 12 Hertz. And now let's change our profile a bit. We need to stop the test and change our settings. Let's run from 20 Hertz and set our start amplitude at 0.5 G. And now let's restart our test again. Yes, our emergency stop was made by our system and nothing was damaged. Everything is okay. So now our system is starting again. And you see it loading. So let's auto scale our graph, check our outputs, and disable our inputs. I think now the test will run correctly. I hope you see it well. Yes, here we started to run the test, and I think you see that our car is moving. Let's wait for 40 Hertz frequency, and we will continue with the next test. I hope you see it. You can see that we're running our test really near to our profile. Here you can see the task and our channels data. Now I think we can stop the test and continue with multi-shaker random test. Let's select it. First of all, let's create a profile. In this test, we will run from 20 Hertz to 40 Hertz with start amplitude of 0.03 to 0.05. After that, we add another line. our end profile will be, end frequency will be 100 Hertz, and amplitude will be 0.05. After that, we apply our settings. Here you can see our profile. Let's go to control loops. You can see that we have our outputs and profiles selected. In this test, we have such feature as different implementations of profiles. In that case, we will have one PSD, but different waveforms for one profile. This feature is used in model analysis. Also, we can set different task profiles for our loops, but in that case, we won't use this. After that, we go to schedule. We will run our test for 30 seconds. After that, we go to control, and here we need to check our control factor and number of averaging. Multi-shaker test is the most useful and important parameters, and let me tell you about them a little bit more. The first control parameter is the number of averaging. This number defines the number of measurements which are taken for one FRF calculation. If we set this value to the maximum, we will get the most stable example of our system, but the reaction time will be rather long. So we recommend to set this value by default, and it will have the value of 8. Also, we have a control factor. Control factor is rather important in multi-shaker tests. In that case, the control factor is a parameter that is responsible for rigorous selection of the matrices based on their singularity. By editing this parameter, you can adjust the sensitivity of the system and filter all unused degenerate controls factor matrices. I'll show you this in our software. Here you can set our control factor, and here you can set number of averaging. After that, we go to channels, set our configuration, and disable unused channels. And now we're ready. We need to set our maximum output voltage to 7 in this test. And now we're ready to start. Now, let's start the test. We need to load it firstly. It takes some time, but I think we will run it really quickly. And let's set common level to 70%. Let me check if we have some questions.
Yes, we do have questions. We have a question if notching is available in Multishaker.
Yes, we have notching limits for multi-shaker tests, and I'll show you it in the next test. Here you can see that our system is starting up. I think you can hear it well. And see that our car is shaking. Yes, we are running our test. Everything is correct, so this time we don't have any issues. I think there was some problems in the sign test, but now we don't have them. So we're running this test really near to our task, and now it's complete. So we can go and continue with multi-shaker shock test, and I'll explain our notching limits for multi-shaker shock test. We need to create our profile right now. Let's edit it. Let's set pulse amplitude to 3G, and we'll set pulse type as half sine, but in our software we have different types. Let me show. We have regular half sine, we have triangle shock shape, we have trapeze, rectangle, initial and final peak sawtooth, we have full sine shock, and heavy sine. After that, we will set our front pulse and post pulse as half sine and apply our settings. Then we go to control loops, check our settings. In schedule, we will set number of shocks to 25. After that, we go to control, check our parameters. And in that case, we will need to set startup end level as 85%. It will help us to start up the test a little bit faster. After that, we set our channels configuration, disable our third and fourth channel, applying settings, saving the test. And in limits, we have a new function as notch limits. Here you can set your upper limit for your available channels. Like here we have two active inputs, first one and the second one. And here you can set your notching limits. Now let's start the test. You can see that the test is loading, but it's okay. Sometimes it may take a little bit more time to load because these tests are more difficult than single shaker tests. And because we set our startup end level as 85%, it will run a bit better. And here you see that our acceleration is rising in the first and the second channel. And I think in a few seconds, we'll receive our shocks. I think you can hear them. And you see that our shaker stable is moving. You can see that we are really close to our task, and I think it's a good result. Do we have some questions? I think yes.
Yes, there was a question if the shakers influence each other, but I think you talked about it.
I mentioned that we have a cross influence between all the shakers in the system, and for controlling it, we use control factor, which can be edited in the settings. You can set its value in the settings. So now let's continue with multi-shaker mix tests. This test will combine sine and random tests, and let's create a profile. We will run from 20 Hertz to 40 Hertz. And here we need to change our amplitude to 0.05 and add another line to 100 Hertz and set the same amplitude. Also, we will add 3 fixed sines To do this, we need to allow sign on random function and set our signs. First one will be at 40 Hertz and its amplitude will be 0.5 G. Let's add another one. It will be at 70 Hertz and have the same amplitude. And the third one will be also fixed with at 30 Hertz and also the same amplitude. Let's apply our settings, and here our fixed signs are represented by these 3 points. Then we go to our control loops. Here we can also set different tasks for different loops, but we won't use this feature because I think in that case it's not appropriate. After that, let's set our test duration to 40 seconds and go to Control tab. Check our settings and then we go to Channels, select our configuration. We need to disable it and then we apply our settings and save the test. Here you can see our graph, and now we are ready to start. Sometimes mixed tests start up a little bit longer than regular tests. We need to wait some time.
Yeah, meanwhile, we also had a question about the maximum frequency for the multi-shaker tests.
In our software, the maximum frequency for multi-shaker tests is 20 kilohertz.
Yeah, and I must say that generally the requirements are for lower frequencies. So what we are offering here, 20 kilohertz, is I think the widest or one of the widest frequency range options there are on the market.
So we're done with this question, and now I can explain this graph. We have a spectrum density versus frequency graph. Here we have our signals, and these arrows show our fixed signs. Here we have 30, 40, and 70 Hertz. And now we're running this test. And I think you can hear it well. And in that case, we got a very loud test. But everything is running correctly, so we don't have any troubles. If you have any questions, type them and we will try to answer them. And now we're ready to continue with our final part of the webinar, multi-shaker field data replication. Let's select it. And for this test, we created an accelerogram from a famous, with a famous song. Let's add it. Let's go to Records. And here we have our accelerogram. And then we go to Control Loops and we need to select it. I need to mention that also in field data replication tests, you can select different signal files for the different loops, and I think that will cover all your needs. After that, we go to Schedule. We will set it as 120 seconds. And in this case, we need to set a really high value for level. Let's set it as 700%. Also, we need to set up our startup control voltage as 1 volt and system response coefficient as 3 decibels. It will help us run the test really quickly and correctly. Let's set up our channels. Disable this third and the fourth one, and I think now we have a question.
Yes, the question is if you can control, if the system can control the shaker simultaneously on different axes.
Yes, we can control an object which is placed on shakers with different axes. For example, on our website, you can see a branded cube, which is connected with 3 shakers on different axes. We can shake an object at the same time at X, Y, and Z axis.
Mm-hmm. And maybe another one. What formats can be imported in Multishaker FDR?
So if you don't have an accelerogram, you can input files. So you press input button, and here you can see that we can input test files like CSV, TXT. Also, we can use sound files like WAV, and I think that's enough to create a profile in field data replication. So I stopped at channels. Let me check again. We have our configuration, and now we're ready to apply our settings. We save the test, and let's start it. Now our profile is being calculated, so we need to wait, but everything will be correct in the end, and sometimes it may happen that you got some issues with the startup. That's because you can have a big file and you need to calculate it a lot. So don't be afraid if you got any unaccepted stops, so everything will be okay. Now you can see that we're starting up. Let's auto scale our graph. I think we're ready. And you can see that our channel is rising. And I think now you can hear this well-known song. And I think you can see the rear part of the car is moving and the profile is running correctly. Let's wait for some time. I think you enjoy this song. And I need to mention that this song is being played through our shakers, and in particular ways it's really important, and you can input different data using audio files and play them using shakers. And now let's stop it. And now I think that's all I wanted to say about multi-shaker tests. So Now I'll pass the microphone to Oleg.
Yeah, thank you, Phillips. We're going to the questions and answers section, but before that, I just want to draw some conclusions. So I hope that you saw our interface, that it is going to be very easy to master, and multi-shaker tests don't seem too complicated in it. We provide multi-shaker tests up to 6 degrees of freedom on 8 shakers, and you can control 2 shakers with one RLC21 controller and 8 shakers with one RLC25 controller. Then now we're offering signed random shock, superimposed test, FDR, and we're developing SRS module for multi-shaker tests. We're offering very good accuracy, wide frequency range, minimum less than 1 degree phase shift, and some special features like different test profiles for different loops. So if you're interested in, if you want to learn more about the multi-shaker module, please contact us and we can send you the demo software where you can try it for yourself and see how it works, see how easy it is to set up. Okay, we have a few questions left in the questions section, and there is yet time. So please, if your question is unanswered during the presentation or in the chat, please repeat it or ask it now. And the first question is, how are the objects fixed during the multi-shaker test? And that's a good question.
The type of the fixture of your object depends on your aim, so you need to select the appropriate shakers and use some different types of fixture for this need. If you have any problems with this, with the fixture of your object, you can write us an email and we will try to help you, and I think we will manage to find a solution for your problem. I think we will help you with the fixture.
Yeah, so it all depends on your particular configuration, on the size, on the length, on the weight, on your shakers. So gotta take it on a case-to-case basis. And also, yeah, Ilya here is telling me that there is a question about the function of oscilloscope, and he wants to talk a little bit more in more detail. So I'm going to give the microphone to Ilya Sokolov here.
Hello. About the oscilloscope. First of all, the oscilloscope here is working like a usual oscilloscope. So we have some, just a second, let me turn off the input. So we have cells and we have to specify some time scale in time units per cell. And we have inputs and output channels. And again, their scale is specified is in unit by cell. The more useful type of the oscilloscope is spectrum scope, where you can see the spectrum of the input channel. It is very useful in case when you're experiencing some problems with the test startup, and you can open the oscilloscope and see if you have, for example, 50 Hz disturbance, and if you have it, you can like try to put a wire between the shaker and the controller, etc., and resolve some ground issue and see if your action helps. Usually this is all about the spectrum scope and oscilloscope, I have to say.
Okay, yeah, thank you. Yeah, I think there are no more questions currently. Maybe if you feel like your question was unanswered during the test, during the presentation in the chat, please respond to the follow-up email that will come tomorrow. We'll be happy to share the presentation, the video as necessary, the demo software for you to try the Multishaker module. If you want to learn more about the sales questions, please contact at rula-tech.com or my email at rula-tech.com. For support, you can contact support or Ilya Sokolov rula-tech.com. You can see and follow our webinars on our website or on our LinkedIn page or other social networks that we're trying to keep up to date. And thank you all so much for your active participation, for your questions. It was great that there is so much interest to Multishaker module. Yeah, we want to wish you happy holidays. It's holiday season. I hope you're already prepared and you have the holiday spirit. This was just like one webinar before the end of the year, and we will come back with more interesting topics in 2022. Stay tuned. Thank you so much and goodbye.